Air is a mixture of gases, including nitrogen, oxygen, and water vapor. The partial pressure of a specific gas in a mixture of gases is the pressure it would exert if all of the other gas components were removed. The total pressure of the mixture is the sum of the partial pressures of the component gases. The partial pressure of water vapor in air depends on weather conditions. It can be as low as 0 or as high as the equilibrium vapor pressure of water at the given temperature. To provide an indication of how much water vapor is in the air, weather forecasters usually give the relative humidity. If the relative humidity is too low, the air contains such a small amount of water vapor that skin and mucous membranes tend to dry out. If the relative humidity is too high, especially on a hot day, we become very uncomfortable and our skin feels sticky. Under such conditions, the air holds so much water vapor that the water exuded by sweat glands cannot evaporate efficiently. The relative humidity is defined as the ratio, expressed as a percentage, of the actual partial pressure of water vapor in the air to the equilibrium vapor pressure at a given temperature. Or, percent relative humidity equals the partial pressure of water vapor divided by the equilibrium vapor pressure at the existing temperature multiplied by 100. The equilibrium vapor pressure is given by the vaporization curve of water and is the pressure of the water vapor in equilibrium with the liquid. At a given temperature, the partial pressure of the water vapor in the air cannot exceed this value. If it did, the vapor would not be in equilibrium with the liquid and would condense as dew or rain to reestablish equilibrium. The vaporization curve of water shown here is a pressure versus temperature graph that indicates the separation between the gas and liquid phases. Suppose T equals 21.0 degrees Celsius. What is the equilibrium vapor pressure? To answer this, we start at 21.0 degrees Celsius on the temperature axis and move vertically to the curve. We then move horizontally to the pressure axis and read the value, which, in this case, is approximately 2.5 times 10 to the third Pascal, which is the correct answer. Now, suppose that the partial pressure of water vapor is 2.0 times 10 to the third Pascal. What is the relative humidity? The percent relative humidity equals the partial pressure of water vapor divided by the equilibrium vapor pressure at the existing temperature multiplied by 100. This is equal to 2.0 times 10 to the third Pascal divided by 2.5 times 10 to the third Pascal times 100, which is equal to 80%. When air containing a given amount of water vapor is cooled, a temperature is reached in which the partial pressure of the vapor equals the equilibrium vapor pressure. This is called saturation, and the temperature at which this occurs is known as the dew point, since dew or fog will form under this condition. The closer the actual temperature is to the dew point, the closer the relative humidity is to 100%. Thus, for fog or dew to form, the air temperature must drop below the dew point. Similarly, water condenses on the outside of a cold glass when the temperature of the air next to the glass falls below the dew point. As a simple example, what is the dew point if the partial vapor pressure of water is 3.5 times 10 to the third Pascal? We start by locating this value of the partial vapor pressure on the pressure axis of the vaporization curve. We then move horizontally to the curve and then vertically downward to the temperature axis. This will be the temperature at which the partial vapor pressure and equilibrium vapor pressure will be equal, resulting in 100% relative humidity. This temperature is also the dew point. In this example, the dew point is 27 degrees Celsius. In summary, the partial pressure of a specific gas in a mixture of gases is the pressure the specific gas would exert if all of the other gas components were removed. The total pressure is the sum of the partial pressures of all of the components. The percent relative humidity is defined as the partial pressure of water vapor divided by the equilibrium vapor pressure of water at the existing temperature multiplied by 100. Next, saturation occurs when the partial and equilibrium vapor pressures are equal, resulting in a relative humidity of 100%. Finally, the temperature at which saturation occurs for a given partial vapor pressure is called the dew point, and is the temperature at which dew or fog will form for that partial pressure.